The following is brought to you by Total Seal Piston Rings, the leader in ring seal technology. TotalSeal.com. Hello and welcome to another edition of Hidden Horsepower presented by Total Seal Piston Rings. I'm Joe Costello, and we've got a very special episode for you this week. Super exciting. You know, Lake Speed, my partner in crime on this show, joining me now. Lake, I love these episodes when you blow the minds of the viewer, of the listener, by digging deeply into the science field. We're talking like deep space technology that we're bringing to the table for our wonderful purpose of building horsepower in our race cars. How are you doing today, Lake?
Oh, Joe, I'm great. I'm so excited. You know, I tend to get a little bit excited about a lot of our guests and everything. This one, I'll have to do my very best to restrain myself from just going completely off the edge because, you know, like in a good superhero saga, how over time you've got all these different character developments and things that are going on. And then right towards the end, there's this episode where they bring everything together. And all of a sudden you see these connections you never saw before. That's the goal of today's episode, because Dr. Peter Lee and his whole group down at Southwest Research, they're the guys who are behind the scenes helping to make the ring seal soup that we've talked about so many times at the Trackside Tech Talks, and that the information that we've given there and we've shown and helped. And Joe, you know it. You're at the NHR races. You hear it and see it. The technology we talk about here on Hidden Horsepower is winning races and winning championships all around the world. And the secret sauce is the guy that we're about to bring on, because the work we've done at Southwest Research is what's made all of this possible. So get ready. This one's going to be good. It might hurt your brain.
Yeah.
But it's going to be worth it.
I'm prepared for my brain to hurt. I like it. I'm excited about it. Obviously, of course, I do a little bit of research into our guest, Dr. Peter Lee. 2011 established the Southwest Research Institute Tribology Lab, evolved it in 2020. They started out with 2 people, 500 square feet. Now there's a dozen people. It's huge. He is winning awards. He is being named fellow Institute engineer, all of these amazing things. But what I believe to be best is to hear directly from the person. So let's bring him on the show. Joining us now, Dr. Peter Lee. Dr. Lee, welcome to Hidden Horsepower. What do you think about what Lake had to say?
I think what Lake had to say is perfectly fair. Everything comes from really good science, and that's what we do here at Southwest Research Institute. It's what we aim to bring to our clients. Some real background behind what's actually happening so they can fully understand and develop stuff properly. So what we've done with Lake has been, I've learned a lot from it as well. It's been absolutely great. And I've been playing with rings and liners for a couple of decades now. Not that I want to admit that.
Wow. So I know you're going to geek out, Lake, but I think it's important to get to know Dr. Lee a little bit. Started out as a automotive engineer, right? Just like everybody else, right? I love cars, went to school, bachelor's degree, automotive engineer, PhD followed, but start out with that initial desire to work with and around automobiles.
Oh, I'd like to say it's a desire. It was a necessity. In the UK, I drove one of the worst vehicles you could possibly have. It was given to me by my grandfather. And if you didn't know how to fix it, you weren't going anywhere. So it was a necessity for me. And then I really kind of grew to love it and being able to fix stuff and do it myself, and decided that it's all very well and good fixing your own stuff, but let's get in there and get paid for it. So I became qualified. Not there anymore as a qualification, but City and Guilds level 1, 2, and 3 in the UK. Did that for a while. Enjoyed it greatly, but you know, a lot of it's done outside in the UK, and it's not really the weather for it. So I kind of decided to go to university and do mechanical engineering, in particular automotive, at University of Leeds. And then from there on, I thought that was going to be it. I was going to go be a carman for Jaguar or Ford or something like that. But seems my skill set in being a mechanic actually got people's attention, let's say. And Shell and Infinium came along and sponsored me to do a PhD. So I had a choice. Do I go looking for a job, or do I take a job that's handed to me on a plate? And it was a paid PhD. And so it involved looking at lubricant degradation in the piston engine. And I went for it. And I'm really glad I did. I mean, it was tribology. And tribology really is something that I felt I understood and had a real feeling for. And I think that's the big difference between those that study it and those that do it. And there's a lot of people out there that are really good tribologists just because you have a feeling for it. It's like a sixth sense.
And Lake, you're one of those guys. Commence the geek out session. Now that everybody understands, you know, Dr. Lee is just like us, trying to keep our cars running and maybe make it as powerful as is possible.
Well, what's neat, like he mentioned, is that, you know, we're just one company, right? Between Total Seal and Rottler, and coming to Southwest Research a couple of years ago, and, you know, kicking off this program to, you know, better understand the fundamentals of the ring and liner contact. And especially now that we're in this new world of, you know, thinner steel rings with the different PVD coatings and things that are available, and, you know, going away from the older, you know, Molly style rings. Of course, anyone that's probably watching this has probably, you know, heard us talk about that in the past. You know, the surface finish of the cylinder has got to be honed where it holds oil, because the rings today don't hold oil, and how the rings in the old days, they held oil. You know, they had porosity and things like that. Well, okay, it's one thing to say that. That's all well and good. And you can maybe draw some, we'll call it correlation, by seeing things in the real world and say, okay, well, we see it did this and we see this one did that, and that must be, that means our theory is correct. That doesn't work for me. And it doesn't work for Hartford. It doesn't work for anybody else at Total Seal. We got to know so we can tell our customers the right thing. The only way to know is to get in there and do fundamental tribology research. And there's no better place in the whole world. There's like one place to call. It's Peter and his group. You know, you go to San Antonio. And what's amazing, and I'll let Peter unpack it, what they've developed down there with the TE77 rig, and how they've adapted it and modified it to do ring on liner testing, is the absolute gold standard for what we're doing. And it's not just about taking a piece of ring and a piece of cylinder line and rubbing it together. Okay, that's, you can see that part, but there's a lot of science around it, especially when it comes to measurements and how we're going to quantify the data that is derived from this test. Because it's amazing. It's actually kind of mind-blowing, really, how much information you can generate from just a couple of hours of rubbing a piston ring against a liner. Now, Peter, why don't you explain a little more about the rig and what we're doing here?
Sure. So, you know, the T77 rig is made by Phoenix Tribology. It comes to us when we order it as a standardized rig. Pretty much everything we do with every rig we obtain at Southwest in the Tribology labs is immediately break the warranty by messing around with it, making it do things it's not supposed to do. That's where the real research happens. So we take the rig, which is essentially just a stationary block and a reciprocating arm. And so the arm reciprocates, and you can put something on the reciprocating arm and something on the stationary block. And that's the whole idea, is tribology, rubbing two things together. It can measure temperatures, it can measure friction. But what we're wanting to do is run a piece of a ring and a piece of a liner together. And that takes a little bit of thinking about, because you think about a ring, when you squeeze it and put it in the bore, it takes a slightly different shape to how it's relaxed. But the bore doesn't relax, and we want that relaxed ring to fit that bore. So we've got particular techniques that we can use where we can cut a section of the ring out, cut a section of the liner out, and put them together and make them run together. And then we also have techniques and things that we've learned partly through calculation, but a lot through just running together and learning these parts, that what you do is you load it in a particular way, you load it through a particular pattern. So you've got a run-in stage, you've got a heavily loaded stage, and you're trying to look at how the two surfaces change with time. And so sometimes you might run a longer test, sometimes you might run a shorter test just to see what's happening with respect to time and how they run together. Because the run-in is really the most important part. It's okay having rings and liners that work, but if they're running badly, they're going to run badly. So the most essential part is right at the beginning of running those in carefully. And that was really what a lot of the work you did with what we did. It was like we looked at the running in and how that changed with different types of parts, different coatings, different surface finishes on the liner and so on, different honings. And how did that change? And that's really, I suppose, a lot of the story that we're going to tell today is how you can see that and how that's changed and how even that's made us think about new approaches and new ways of doing this in the future.
Absolutely.
Yeah.
Right. So Joe, I think you've got some video, right? So why don't we show some of the pictures, because where we begin, like Peter said, you take a real liner and
let's
a real
start
ring.
with the process. Exactly. Walk us through.
We got to take that liner and machine it down and cut up and make these little pieces. And then once you take those pieces, now you can put that piece in the rig and begin to reciprocate it. And like Peter said, you can do that over different speeds and loads and temperatures and run it for different times. And we worked really hard to come up with a procedure that's slow-mo, right?
That's slow-mo. See, like that's pretty quick as it is already.
So you can actually kind of see what's going on. But one nice thing is that it's running in that bath of oil. So we can also apply used oil analysis by taking that sample, running it through the ICP, which basically looks at all the medical particles in the oil, and then we can begin to judge and see, okay, we can see how much wear you can see with your eyes on the liner, but then the used oil analysis tells you something else. But we got to go one step beyond just trusting your eyes. So they have a very high-powered Keyence microscope that can go in and scan and evaluate those parts, both the liner and the ring. And because of its ability, the magnification ability to really go in there and see what's happening, especially when it comes to the coatings. If you can see if there's a delamination. So like a couple of the things that we tried over time was, okay, here, let's run, regular roll type ring. Let's run, a chrome nitrided, a CRN, a PVD coated ring. And you can see with this what effect that has, not only from the used oil analysis, what the total wear are, but when you get in and begin looking at the coatings, we tried some different dual layer coatings. And with the Keyence, you can go in there and see the delamination, where if those two coatings didn't adhere to each other properly because they're different materials, you can see those pieces come off. And of course, what we saw was every time there was delamination, there was higher wear.
Well, yeah, and the score marks, you get the scratching that's going. You end up with this third body wear, which is where you've got an extra particle in there that doesn't want to be in there and gets dragged across the surface and damages it. And of course, we say about running in, immediately you've got a scratch in there, you've got a pathway for blow-by. So you're not getting as much power, you're losing some of that down into your engine. So that's like you say, it's the running in that's the most important part. And we did see delamination on a couple of things and the poor results that we obtained from that. Yeah.
And the thing, like you said, Peter is spot on, is that first 30 minutes to an hour, that running in is so critical. And one of the things we found quite quickly is that if you have that very rough surface that can work against the hard ring to try to bed the two in, what will typically happen is that it's so rough that the wear debris then becomes that third party abrasive that Peter was talking about, and then it just wipes out the surface because it's so rough that it's not a stable surface, that as those peaks and asperities begin to wear in, they just break off, and now it becomes this third party abrasive, and it's just rolling all around, just causing chaos and havoc and damage. So it doesn't take very long to see that we were able to find the right balance of those valley depths we talked about, Joe. I'm sure you've been enough.
Yes.
Trackside Tech Talks, buddy. I could let you tell this part, right? You know, we have to have those valleys that need to hold the oil, but we got to have that flat area that can hold the load. And, you know, Peter, he saw it. There was a gigantic difference in what the surface finish would do with the same oil chemistry. But then, you know, the oil geek in me loved it, that fact that we could also change the oil chemistry and change that window. You know, that there's more than one lever to pull here. It's not a one-trick pony. And that Peter, is that the complexity of all the results. And of course, yeah, I couldn't help myself. I was like a kid in a candy store. There were so many variables we could test that the amount of variables we had was quite large.
You got pretty big. That was a stupid sized test matrix.
Yeah.
You learned a huge amount from it, though.
Right, exactly. So it was worth the pain to get there, because, you know, at the end of the day, Joe, we'll call it the recipe that came out of that testing is, you know, that's what Greg and those guys were using to go win races. You know, it's that technology went straight from the lab right to the racetrack and went straight to victory lane because it was that good. And
has Peter ever seen this? Like, I think it's, you know, it never gets old to see this. Is there something worth Greg Anderson watching a Total Seal Tech Talk at the pit area? You seem to observe. So you tell me, that area that they talk about, is there something worth learning? Because I'm going to take this clip of audio right now and play it tomorrow.
I will tell you from the bottom of my heart, Joe, did I learn something that day that I listened to that first seminar? You darn tootin' I did. I absolutely did. And it has helped me in my race program. And thank you, Lake. Thank you, Keith. Thank you, Matt Hartford, and all the Total Seal guys. Thank you to all the Rottler guys. I've now got a beautiful new Rottler CNC hone in my shop that, you know, I'm not going to lie, it's helped my project. It's helped my program. And I learned that day that I listened to those guys, maybe we are missing something here. So, yeah, I can't lie. And I probably shouldn't have told the world that, but it is the truth. It has absolutely helped my program. I'm not going to deny it. And I thank all those guys for what they've done and what they are doing. And yes, anybody that gets a chance to sit in on one of these seminars, don't miss it.
Wow. And you could have said absolutely not. Nope. Didn't help at all.
I don't know how to lie.
He doesn't know how to lie. Like, I got to squeeze that in every once in a while, Dr. Lee. Got to do it.
Well, if he probably can't say it because he's got NDAs, you know, more than we have NDAs. But we're not the only people that have ever come knocked on their door where they had problems and they left with solutions that went and won races like the next weekend. You know,
we've had a few.
Yeah. So yeah, it's the people that know where to go. It's in San Antonio, and you go get things done, whether you're dealing with camshafts or piston rings, or, you know, I won't want to take Peter's thunder, let him explain, you know, what Southwest Research is all about, because we're talking about rings and liners and this little bit of testing and the metrology that we're using to understand the results from those tests. But there's a lot more going on at Southwest Research than just tribology. Yeah,
a huge amount. So we have a catchphrase, which is deep sea to deep space. And it sounds kind of over the top, but it's completely genuine. You know, we have so many different divisions out here working in so many different areas. We have nearly 500 PhDs out here. It's the challenges that we get brought to us are absolutely amazing. And being in the tribology group is even better for me personally, because they have problems coming to other groups that they need some tribology help with. So we literally have stuff up there that we've helped solve, and stuff down the bottom of the sea that we've helped with, and all types of different transportation, hip joints, you know, other stuff like that. It's everything. There's a company out there that has been looking at how to make your insect repellent feel better when you spread it on your arm, and how it feels like when it dries, and when your hair's dry on it and so on. It's just like, it's really weird stuff that we do, but it's great fun. It really is.
Lake's jealous. I could see Lake's jealous. Crazy
It is.
problems to solve. The things I gotta get in here and do it and test. I love it.
I covet the days that I get to go down there and I get paid to go to work. It's not work, man. And Hartford, everyone knows. When I get to go to Southwest and we get to go down there and we're in the lab for a couple of days working on stuff, that might as well be paid time off because that's as close to a vacation as it gets for me. I love that. I mean, it's like going to Shavers and hanging out and doing dyno work. That ain't work. You know, I'm not even gonna try to lie and it's really hard work. No, it's not. It's fun.
Well, that's good. It's a passion, but that's why you're good at it, right? Like both of you guys, you're good at it because in the end, it's this this passion. But Dr. Lee, from 2 people and 500 square feet, now there's over a dozen people, and this thing is big. Obviously, there's a very strong market for what you do. As you said, like we can't advance the ball if we don't know these elements.
Yeah, I think it's a particular approach that we take here at Southwest, where when people come into the labs, they come with a problem or they're looking for a better solution. And we don't just take that and go through some standardized testing and try and solve it for them using some ASTM standards. We take what they've got, we actually turn it into, we break it down into what's the environment, what are the materials and everything else. And if at all possible, we'll actually use the real parts, just like we do with the rings and liners in the T77. You know, we'll cut something up and we'll make it fit in the test rig. So we're using the real surfaces. We'll duplicate what they're finding in the field and what the issue is. And then we'll try and solve that problem by throwing different ideas at it, whether that be lubricants, coatings, different surface finishes, scientific approach. Do the testing in what are called tribometers, which are basically things that rub things together, put simply. And then after that, once we've got all the data, we can take it back out in the field and scale it back up and come up with a solution. And it's getting those solutions and really finding a real solution by doing that is what makes this job so much fun. And having things out there that are now working or working better or lasting longer or producing fewer emissions and whatever it is, whatever the goal is, it actually functioning and working properly once you get it back out in the field it's fantastic. It's a fantastic feeling.
It really is, because it eliminates the throwing darts against the wall, hoping to find the one that, you know, hits, you know, the bullseye. Just like Peter said, if you have a problem, or like in our case, you're just looking for a better solution, when you can go into the lab environment and eliminate all the extraneous noise and then just focus on that fundamental contact. And like he said, it's the key that you have the right materials, you have the right geometry, the speeds and the loads. And, you know, like in one case, we've been working on a project together related to this where we needed to have fuel dilution. So they came up with a way to be able to dilute the oil with the proper amount of fuel so that it simulates that running environment, because that was part of the situation. And like you said, we were able to then replicate in the lab without all the noise, the exact failure mode that was in the field. Now we can begin to work on all the different things, see which one moves the needle the most. Take that package, once you find the solution, put it back in the real world, and it works just the same as it did in the lab, because you did your homework right. And you went in and you paid attention to the right details, and you moved in a methodical, scientific fashion. You didn't change more than one thing at a time. And doing that is such an incredibly powerful thing that it is actually, I truly believe it's more time and cost effective than just throwing stuff against the wall, hoping for something to stick. Because when you go out this process, yeah, it's going to take a little bit longer than if you maybe got lucky on the first throw. But the reality is most people don't get lucky on the first throw. And if you do, you typically don't know why it worked.
Yeah.
You just knew that it worked, but you don't understand the fundamentals behind it. The real power is knowing the why behind the what. And I feel like that's what Peter and his group there is so good at doing, is helping you to understand the why behind the what. Because then if the rules change or whatever else happens, your fundamental understanding didn't change. You already have that. You may have to adapt it to the next situation, but you're beginning from a basis of knowledge, as opposed to saying, well, what we used to have worked, but that changed, and now we're starting from square one. You don't ever have to start from square one again. You just keep building on that knowledge base. And that's one of the just incredible things about down there. Like you said, there's so many different departments. There's so many people there that have seen all these incredible things. I mean, it's literally, if you think about it, from deep sea to deep space, it covers a lot of ground. there's a lot of experience there, a lot of resource, and the problem you're having probably isn't unique to just you. That there's probably information there that can help you get a little bit closer to speeding up and getting to the right answer, or a better answer than what you have right now.
Yep, absolutely. Completely, Lake. And you're right, it's that background of knowledge. Having that background of knowledge from the first set of testing or the second set of testing that you did allows you to pivot faster if you need to, if something changes on you. So let's say in racing, say that they change the rules and you're not allowed to use a coating in a particular place anymore, then that's fine. You've already got a certain background of knowledge that you can fall back on, so you're not starting from ground zero again. It's just things like that. It's just that's precisely the right word, Lake. It's knowledge. Having the knowledge, not just the answer, but the knowledge that's the foundation underneath that answer that allows you to build on it. That's what makes the real big difference.
And like you said, the fact that you have so many different departments that are engaged in so many different things. For example, when we were looking at the different coatings and we saw the delamination of the two coatings, an hour later, we're across campus in your coating lab.
Yeah.
Because you have people there that do coatings. And it's like,
lab.
Well,
yep, absolutely. Just go find the right person. And to be honest, that's partly what drew me to Southwest in the first place. I was at the University of Leeds in the UK doing a Royal Academy of Engineering Research Fellowship, and that was great. But being asked to come here and establish these labs, and the fact that I can have somebody call in the morning and say, hey, we've got this really big problem. What can you do to help? And I'd say, ask a few questions, get some ideas of where the problem might be coming from, what potential solutions there might be. And then by the afternoon, get them back on the call with 4 or 5 of us from around the Institute in those specialist fields. We can have solved the problem basically by the end of the day, unless there's need to do some testing to prove out the theories. But you can have answers so much faster, and it's time efficient and it's cost efficient, and it allows answers to questions that otherwise would not get answers because you don't have the right people in the right place.
Right. And I think our experience with the coatings is a perfect example of that. That here we are running these tests and we see this coating delamination. And like I said, we have the coating delamination in the morning and we can see it. By the afternoon, we're over in Dr. Lynn's office looking at other coatings and talking about coatings. So elaborate on what came out of that, because to me that it's still like a surreal moment. Like, I can't believe that this actually really happened, that I was there. I feel like I was sure. Out of body experience. Like, yeah, that really happened. No, I was really there. That's kind of crazy.
Yeah, we were there. It was we went into the lab. We're looking at different coatings. We're talking about different coatings. One of the big things that you and I noticed in our testing was that run-in works a lot better with a softer coating, which is why we were trying dual coatings. But if you have a soft coating, it's not going to be durable. You can't have a piston ring where you've got to tear the engine down and rebuild it in a normal vehicle every 10,000 miles because your coating's worn off. So you need a durable, preferably low friction coating so you get your fuel economy. But we tried the 2 different coatings, one on top of the other, and the combinations of that weren't working. Well, we're just standing there in the lab, and I don't recall whether it was you or I, but somebody just said, well, the coating that Southwest developed a while ago that we know is a really good coating for low friction and high durability, why can't we make that soft? And better still, why can't we, as we're laying it down, have it hard and then go soft just on the surface of it so that we've got running, and then when that bit's worn out and we've got nice running, we've then got low friction, high durability. And I remember Dr. Lynn saying, I don't know, we haven't tried it. Well, there was our patent, and then he went and tried it, and hey, it worked.
Yes, so, it does work.
Yeah,
it works really good. Solved all the problems of, like you said, the research said that softer outer coating is preferable. But when you have the 2 different materials, if there could be that adhesion issue, the fact that it's all one material and it's just the hardness was tuned via the process, eliminated that problem.
Yeah.
So it's all the benefit of when the successful trial was done without any of the negative trial. But then along comes this great other benefit, is that it's lower friction than the other coating combination was. So not only did it wear better, or do the proper amount of wear and then stop wearing when you want to stop wearing, it was also like significantly lower friction. So when we put it in the engine, we saw that increase in peak torque, which was, from my perspective, that was the icing on the cake. But it only just made, more peak power at high RPM. I'm not sure we would have taken it. We've been happy about it, but I wouldn't have felt as confident about it because, Joe, we've done all this work with Ben Strader, and when he was on last time, we talked about the combustion analysis and how we can look at that in-cylinder pressure. Well, peak cylinder pressure is peak torque. If you look at, friction, it's basically the coefficient of friction times load. Well, in a piston ring environment, that load comes from cylinder pressure. So if the coating was really doing in the engine what we saw it doing on the test rig, then the biggest gain should come at peak cylinder pressure. And that's exactly what we saw on the dyno. And I get excited even right now thinking about it. It was like eureka moment. It's like, yes, this is real. It's not just some anomaly of a test rig or something like that. No, like we did it on the rig multiple times and it showed up. And now we've done it in engines multiple times and it shows up. It's the absolute real deal that solves all those problems. And I still kind of haven't got my head around what this can mean yet, because we've lived in this world where you had either a hard ring or a soft ring, and you had to what side of the knife you want to die on, right? It's like, okay, if I've got this soft ring, well, better make everything really smooth and do this so that it doesn't wear it out too quickly. And then if it's really hard, well, I got to make it a little bit rough. Or I have this really prolonged break-in where I'm giving up efficiency and higher blow-by. You never prepared yourself to think about a scenario where it's like, you can have your cake and eat it too. And what does that mean in terms of, could we optimize the surface finish even more? I mean, I don't think we have any of the pictures to show right now, but Peter, when you showed me the picture of the run liner from the variable hardness coating, it didn't look like it had even run.
No, exactly. It was beautifully run in. It really didn't look like it had run at all. It's that gentle That soft coating is so gentle with running it in. As you say, it's not pulling out the asperities, it's not knocking off the big asperities, it's not creating wear like it normally would. So you're losing that. So you've got this super gentle, smooth running in. You've got a beautiful smooth surface on the ring, a beautiful smooth surface, but with the valleys necessary to retain the oil on the liner. And then at the end of that, what you've got is lower blow by. So you're retaining more of your horsepower. You're getting your better horsepower, and you're getting your fuel economy. And you talk about it from a racing perspective, and I'm talking about fuel economy because everybody's driving towards electric vehicles to try and look after what's going on in the world. But that's fine. But what about all the billions of cars that are already out there? If you think about all the combustion engines that are going out there, if you put this coating and made this coating work in those, it would make a significant difference across the whole planet. And it's something that perhaps manufacturers will look at. Perhaps it can be an aftermarket for when people have engines rebuilt or something. I don't know where it's going to go. Nobody ever does, but there's a huge potential in it. Absolutely.
Yeah, it's a game changer. It's absolutely a game-changing technology. We've never had that ability to have both the soft and the hard, and the benefits of both all in one without any of the downside, the delamination. It's pretty incredible what we've seen so far.
And I don't think we finished playing with it because, as you alluded to earlier, you know, we had liner sections that we already had. We developed this coating. We ran this coating on those liner sections. Okay, now we've got really good coating, but we haven't done any work to look at what type of finish on the liner would be best to function with this coating. We've just done the coating on the liner that we had. So I think there's potential to expand it even further.
We've heard that one before, Lake. Like the whole thing, you got to start again now. Now that we've created this, then we have to go back and reevaluate everything that we've ever done because we could maybe make it a whole lot better. That sounds very car racing to me.
Oh, that's what it is. You got to keep getting better, and the more you learn, the more you can progress, and now you can step back and say, okay, let's think about this. You know, one of the things we haven't run yet is sumo bore. You know, one of the plasma spray bores with this technology yet. That's something we definitely want to do because it's a very different kind of surface. So it would be interesting to see how does this coating work with that kind of bore material, and so that's what's becoming next for certain, along with other developments. But you know, the great thing is we've went from the lab to a full running engine, and then we've actually put coated rings in real race engines that have gone out there and won races and put a lot of time on them, come back, and again, the rings look good, the bores look good. That, like Peter said, it's so gentle on the running in that it doesn't cause that wear, that high level of wear that you can never reverse, you know, because the highest amount of wear that's ever going to be normal for an engine is during running in. So if you can reduce that amount of wear during running in, you thereby extend the life of that part. It can go further. And especially once it's good and stable, you get that stable surface, that will be a more durable surface. So for some people in their world, it's all about the horsepower. It's all about whatever that fuel economy gained is, and you'll give up whatever it takes to get there. But there's other people that are looking for durability, and they're not as concerned about efficiency, but they want that part to live. And what I think we're seeing here is that when you get the running in part right, and you create a stable surface, you're going to get durability. And if you can make that stable surface low friction, then you can have your cake and eat it too, which still sounds too good to be true. It's still kind of like, got to pinch myself sometimes and say, are you just talking out of your butt, or what's going on here? Because this is kind of nuts, but the data backs it up that it's real. We haven't seen any downsides to it yet.
No, that's precisely it. The data's there. If the foundations are there with the data that we've obtained and got, and we've done the stepwise approach, which is the beauty of it. You know, you do the research work in the lab, as you said, and then you take it out to an engine on a dynamometer. And once that's shown it, then you can take it out to the track and actually see it for real. And it's that stepwise approach, and we haven't seen the downside to it yet. It doesn't mean there isn't one. Maybe there'll be a downside. Maybe the coating will suddenly delaminate and come off at 500 hours or something. Who knows? We haven't tested it that long yet, but let's wait and see what happens.
No, yeah, the results are certainly promising enough that we're not stopping.
Yeah.
We're gonna keep pushing because it's too good, you know.
So there's one more video, guys, and I want to see it because it's super cool. But is it applicable right now? Should I just bring it up?
Oh yeah, why not?
Yeah, because this is what do we got going on here?
So this is, we're looking at a 3D profilometer. So anyone that's been a Hidden Horsepower listener for a while knows about profilometers, and we've always used the 2D one with the stylus. Well, down there they have the trick one. The 3D is optical, and what we're looking at is a wear track. So that part in red over to the left there, that's the unrun part, and the part in the green going back to the right, that is where the ring has been running. But what's really neat as you watch this, you know, piston rings are barrel shaped on the face. So as that thing rolls to the side, notice that right there where the ring stops moving, there's that little bit of a barrel, because that's where the ring has stopped moving, and that's where the highest amount of wear is going to be. And you can see that it's a little bit lower than the rest of it. And as it moves away, going back to the right there, you see that it starts to get a little bit more red the further you go to the right. That's because that's where the oil film is building. As the ring moves away, now you begin to build the oil film. You go from that boundary condition where the ring has stopped. Now we begin to build an oil film as it moves away, and you can see that color change progression. I mean, I know it sounds like hyperbole, right? And I'm just so excited about all these things. But Peter was there. I literally like pumped my fist in the air when we saw that. I'm like, because in the world of tribology, we have what's called the SwRI curve. So that is looking at boundary, mixed, hydrodynamic, all three films, because all three stages of lubrication. And you can literally see the SwRI curve in real life on that picture. That's the coolest damn thing I've ever seen. It's amazing. Now, it took it wearing a lot to be able to do that. So that's actually not a great result. But it's really cool looking, though. Yeah. You know, it's amazing. But again, that's why going to his place is so fun.
We're glad we can entertain you.
Yes, that's really what it's all about in the end. All right, close it in on the stretch run of the show here. And so, like, is there anything that you really wanted to drive home? Because I do want to ask Dr. Lee for a war story or two. If he, you know, like, he's building rigs, they're doing all kinds of stuff. They're doing things that we've never dreamed of. I'm sure if he could tell us one, like, I'm kind of putting it out there so you can maybe be thinking about it. You know, we like hearing stories of, you know, things blowing up or breaking or experiments that have gone wrong or not according to plan, or who knows, maybe a great success. Who knows? But while he ponders that a little bit, Lake, was there anything that you wanted to drive home that we didn't quite get to just yet?
No, I think we covered the key things. Is that, you know, I'm very thankful, you know, on a personal level and a professional level, to Peter and all the guys there, you know, Mike Manier and Isaiah and Carlos and Andrew. The whole crew he's got down there is fantastic. And they've been nothing but great hosts for me when we come down. And it is really great, like I said, to see the fruits of that labor, you know, not only make a difference early on the racetrack, but then to develop this new coating to be part of that and be able to see it being, you know, move forward and put into the field and tested. And there's, you know, more to come on that. It's just exciting to see tribology, which is a science that I love, being able to really make a difference in racing, in which is the environment that I grew up in. It's like, it's makes my heart feel good, Joe.
Good. Well, you know, like, if only everybody got as much joy out of their job as Lake Speed does, the world would be a better place.
Yeah. It's people that know me. If you really know me, you know this is genuine. Some people will watch this stuff and say, that guy's he's full of it. Wow. But if you know me, you know this is real. This isn't fake. No. It's all real, baby.
Dr. Lee, do you agree?
I do. Absolutely. That's why I love my job so much. Come in, don't know what's going to come up. It's always a challenge. It's always fun, and it's tribology. And people who haven't got into tribology, you're missing something. You need to go see a therapist or something. You really do need to get into tribology. It's amazing.
The next big fad, it's coming down the pike, man. Tribology. Everybody's going to be doing it. Now, you guys don't want that. You want to keep it to yourselves. I understand. All right, Dr. Lee, can you share a war story, something, a problem solved, a great thing?
Yeah,
you got these NDAs and stuff.
I can share one with you. It's old enough. It's now out of its NDA, so I'll cover this one. It was probably about 8 years ago, and we were using a block on ring tester. So that is basically a circle that rotates with a block on the top that you load in a bath of oil. And we used that to solve a NASCAR issue. One of the Ford engines, one particular team was having their engine blow up all the time, every single race. And it was down to the camshaft and the lifter. And both were coated with DLC. And they were trying to work out what was happening. And they came to us out of desperation and said, what can you do? And I said, well, send me your camshaft. Again, coatings department. We went down there. We cross-sectioned it. We looked at it. We saw what type of DLC it was and how it was made up, and duplicated that in our coating system, put it onto the blocks and the rings, ran them together with the oil, found out that, yes, they were failing, and almost certainly it was one of the additives in the oil wasn't playing nice with the DLC and the DLC coatings. Went back to the oil company, had a whole group of oils blended up, same oil, but minus one additive, until we found a test which we ran, and the additive, obviously that one was missing, and the test was successful. Told them it worked. They reblended, we ran it. It worked beautifully with the reblend. Sent it across to the engine on the dyno. They ran it, and on the Sunday they went and won the race. So it was the only time I've actually watched a NASCAR race, because I don't have TV. It took a lot of effort to find a TV to watch it, but it was that is what I mean when I say it's beautiful to have your problems come in, break them down, find a solution, and then put it out in the real world and see it make a big difference. And that was a very fast turnaround. We turned the lab on 24/7 for probably about the only time we've ever done that while we've been running the labs. And we found that solution and had the problem solved within 1 week. So it was pretty cool.
Very cool. Did you say they won the race, or they ran?
Did. They actually won the race.
They won the race.
From blowing engines up to winning the race.
That's amazing.
Yes.
And you also said you don't have TV.
Yeah, we don't have TV. So
probably a good idea. Probably a good idea. All right. So at the end of each Hidden Horsepower episode, I always ask our engine builder celebrity. I feel like there's advice that can be shared with the next generation of young lake speeds out there who maybe they don't know what they want to do just yet, or they're thinking about it. A shortcut, some piece of advice that could be helpful to them in their careers. Obviously, follow your passion is clearly one of them. But Dr. Lee, do you have something that you could impart to the audience?
Tribology. Get yourself out there, learn what tribology is. Tribology doesn't just come from mechanical engineering. It comes from physicists, mechanical engineers, chemical engineers. It's everything together, and you can't do it by yourself. You need everybody else. So if just look at what it is, find out what it is. There are a couple of tribology minors out there you can go and do to get educated that aren't particularly expensive or difficult. And if you find you've got a passion for it, follow it. Just follow it. There are so many problems out there that need solving that tribologists can solve, and just go for it. Just have fun in life. If you don't have fun in life, what's the point in being here?
Yeah, I agree. Lake, you got a final question for Dr. Lee before we let him go? What an amazing episode. I know you're super. You got the cat that swallowed the canary grin going on right now. I know you know it.
Wow, he said it perfectly. I mean, tribology is an amazing science. I'm passionate about it because it works in our space. Because I love engines, I love racing, and engines are just, it's information overload when it comes to tribology, right? From what happens in with the rings and liners, with the camshafts and lifters and the valve train. There's so many pieces in an engine where tribology plays that huge role. So I love engines. I love tribology. It's great. But like Peter said, there's all kinds of other areas where tribology plays a giant role. It's one of like the hidden sciences in the world. I mean, everything that has a lubricant in it or a coating on it is essentially tribology, but we don't think about it. And obviously, my background, we know that when we took and applied tribology to race cars, it made a giant difference in the performance of those race cars. There's many wins, many championships came from that. And I just think that, everybody else that can pick up that mindset and apply the science of tribology to what they're doing, you're going to make what you're doing better. And that's what's amazing. And the wonderful thing is there's incredible resources like Dr. Lee's group at Southwest Research that can help companies get answers faster, that you're not in this alone. There's a tremendous community out there that wants to help. I've never met anybody at any STLE meeting that doesn't want to help. Everyone seems to really have that same kind of spirit of they love solving problems and figuring things out, and getting to the right answer is this kind of, it's almost in the nature of the beast, which makes it a great community. And I think that anyone that's interested in this, like Peter said, go for it. If this is interesting at all, absolutely don't look back. Go for it. I don't regret it for a moment. Best thing ever happened in my life was getting involved in tribology, and you'll take it from my cold, dead hand.
Or living hand. We don't need to go there.
As long as I'm alive, I'm going to be doing it, buddy. It'll be my cold, dead hand.
It's amazing. It's amazing. Dr. Lee, thank you for joining us on this episode of Hidden Horsepower. I really appreciate just the understanding of what you are solving. And I did a Google search. I recommend everybody. You got some interesting projects coming up as well. I know you can't really talk about them, but always a new challenge, right? Thank you for spending time with us here on the show.
Been a pleasure.
Excellent. Lake, you've really outdone yourself this time. Yeah, good
like
stuff.
I said at the very beginning, it's like, in the superhero movies saga, at some point you have to have that episode where you see how all the different pieces fit together. And I feel like this is like the episode of Hidden Horsepower that kind of underpins all of Hidden Horsepower. And of course, I see it from a tribology perspective, so I know I'm biased. I know that. But
all right. But for people who want their engines to go faster, right? Those are the guys that are watching the show. They're working in the engine shops. They now have a deeper understanding. In what way can they apply what you've learned to their engine? How do they get a hold of you guys at Total Seal so that they can evolve this conversation and take advantage of all this research?
Well, the great thing is, the Total Seal YouTube channel is, chock-a-block full of great testing videos. And there's lots of little nuggets in there. So if you haven't gone in there and really looked at even some of the old terrible videos, I know some of the old ones are really bad, but just try to get past the bad audio, bad video production, and the annoying host. But look for the data. There's a lot of good information in the videos on the Total Seal channel. Once you've got that and you kind of have the understanding, then don't hesitate. Reach out. Our guys, call 623-587-7400. That's the tech number. We've got really, really great guys between Keith and Kevin and August. These guys have tons of engine building experience and all different kinds of things. And they're there. They're ready to help you get the right ring set, can give you advice on honing and stuff like that to make sure that you get the right ring set for your application. That way you can take advantages of all the science and the ability that tribology gives you. You can get that from a piston ring. You can put it into place in your engine. All it takes is one phone call, 623-587-7400.
How about this guy? And you can get him on social media, of course. And now Hidden Horsepower has our all new YouTube channel. We encourage everybody to share it with all your friends, right? We got to get as many people out there. And with episodes like this one, I know those numbers are going to be skyrocketing. Lake, thank you so much. Great job.
Thank you, Joe.
He is Lake Speed Jr. head tribologist at Total Seal Piston Rings. And I'm Joe Costello. What an episode. Dr. Peter Lee, an amazing job. Appreciate everybody out there. And remember the social media, Facebook, YouTube, everywhere you can follow along, Total Seal Piston Rings and Hidden Horsepower. This was a wild one. Dr. Peter Lee, appreciate you guys. Thank you so much. We'll see you on the next episode of Hidden Horsepower, presented by Total Seal.